roll that over and hop right into the next talk from Pittman and their team, supporting real-time EVA science via horizontally integrated informatics structures across Artemis activities.
Okay, can you guys hear me?
Yes.
Great. Hi, everybody. I am Cameron Pittman. I'm a software engineer in Ares working on the EVA Mission Systems software project. And right now I'm primarily working alongside Ben Feist, who is the, excuse me, the EVA decision support interface maestro himself on the code of software you just saw in Matthew's presentation. I'm also an autonomy researcher. This fall I'll actually be starting full-time as a grad student at MIT AeroAstro, researching the problem of multi-agent activity planning and execution under delayed communications. So what this means is that I'm lucky to work on a team where we spend all of our time thinking about the what and when of EVAs. I also get to think about the question of how, as in how do we build the software tools to help people decide what should happen when. So this talk is about what you can do as a scientific and operations communities to help us build useful decision support systems. I'll try to keep this presentation short and sweet, so we'll probably finish in under 10 minutes as a respect to your time. So I'll give you the spoiler now. It's just timestamps. Just make sure your data has accurate and detailed timestamps. That's it. So next slide. Alrighty. So now that I've given you the spoiler, I want to bring up this idea of mission context and how you can think of it as a story. So mission context is all the goings on when data was collected. It's the idea of elevating a particular rock sample from just spectroscopy data and such, sorry, I'm not a geologist, to becoming a sample that was taken 4 hours into the EVA by crew member X using tool Y at location Z, and it took them N attempts, and here is every image from that moment in time, and here is the flight to ground discussion that was happening at that time. And the way that I like to think of it is that if this were a TV show, your data in and of itself is a couple lines of dialogue. The context is everything else that was going on, which gives your dialogue meaning in the overall story. Next slide. All right. So then that begs the question of how do you build a story around data you didn't collect? And then ultimately, who's going to be benefiting from your part of the story? So I'll be addressing the first question now, and the second question will come at the end of the presentation. Next slide, please. And you can actually just jump again to the next slide. Thank you. So the main issue with building this story is that there's a disconnect between everyone who is analyzing the data and the persons or agents responsible for collecting that data. There's also going to be an incredibly diverse array of data collected during Artemis. Now, I don't know, and I doubt anybody else does, the full breadth of data that we'll be collecting during Artemis 3, let alone in later missions. So we need a way to think about and start developing mission support tools without knowing the exact data that decision makers will need during a mission. Next slide, please. So our solution is to use the one datum that we know we'll have, which is time. Every piece of data needs to be timestamped, and those timestamps should be accurate to the second, ideally. If you do that, we can put it in an interface. And this will help at all phases of the mission, planning, training, flying, and then the eventual post-mission analysis, along with exploration that Matthew just discussed. I also want to call out the fact that keeping diligent timestamps will help with planning over time delay, which will impact Mars missions and may in fact even impact lunar missions. Lunar missions may suffer from delayed or missing communications just simply due to infrastructure issues, in which case you're going to have the same kind of communication problems on the moon as you do on Mars. It's also an absolute nightmare to do time math by hand. And so if you give us accurate timestamps with your data, we can do a lot of time math and make your life easier. So all of that is going to beg the question of how do you build an interface for such decision support systems? Matthew just described some of them in his last presentation, but I want to call out some specific examples here. Next slide, please. So first is Ben Feist's Apollo in Real-Time website. Websites are great because you don't have to ask users to install anything. You just click on a URL, and there is the information you asked for. I took this screenshot of Buzz Aldrin during core sampling on Apollo 11, and time is front and center in this interface, and it ties everything together. Next slide, please. So note the multi-level timeline at the top. Next slide. Sorry, these are going to be coming rapid fire here. Next slide. Thanks. So what is time? We have that timeline at the top, and the timeline itself includes a lot of clues about the context for the moment. So if you look at this, you'll notice that there's a lot of context in that timeline. It's not just simply a series of numbers. You also have information about the events going on. You have some basically, little markers that are indicating when videos and images are present. So as a user, you can quickly jump to any moment in the mission and have an idea of what data might be there. Next slide, please. One more, sorry. There are a lot of these. So you know, because of the timeline at the top, that all the data that you see here in this blue box is related to this exact moment in time. There's no question about it. This video, this imagery, and these transcripts all describe what's happening then. But it's not just the audio and video media that we can correlate with time. Next slide, please. So this is that exact same moment. In this view, the user swapped out the still imagery for sample collection data. We can see sample photography, both in situ and what looks like came from later in a lab. We can see links to MoonDB and other sample curation websites. And because we have the exact moment in time when this sample was collected, we can create an interface where researchers can easily find the context of that data in the overall story of the mission. So if you look at the transcript on the left, you can see that the observations Buzz and Neil were making about the sample collection, like it almost looks wet, are there. And without timestamps, it would be next to impossible to make these connections. But with this kind of time-aligned interface, it becomes trivial. So let's take a look at another example from an Earth-based analog. Next slide, please. So this example is coming from the RISE 2 project, which is obviously after RISE 1. RISE is the Remote In Situ and Synchrotron Studies for Science and Exploration. This is a survey project, and it's an amazing opportunity for us to investigate the same kinds of field science data interface problems that we're going to be facing on Artemis. If you're not familiar with the project, it's an analog where scientists, astronauts, and EVA operations personnel simulate planetary exploration through field geology, much like many of these other analogs we've discussed. We were supposed to go out in the field last year, but then COVID, of course. So the questions we want to address are on the same kind of data integration for real-time decision-making and post-hoc analysis that we'll have on Artemis. And so I want to show you a prototype interface that Ben built for the first RISE project. Next slide, please. So it looks pretty similar to the Apollo in real-time interface, but a little bit simpler because we don't quite have as many data products in this one. Next slide, please. But you'll once again notice that time is playing a prominent role. You can see the timeline at the bottom. Next slide. We also have various camera imagery, including body-worn GoPro, still imagery, and even some drone footage giving situational awareness. Next slide. And then what's really cool is that we also have GPS data, which makes it possible to integrate a real map in this portion of the screen. That's a real interactive map that the users can investigate. We're just starting to scratch the surface of GIS and interfaces. So I'm excited that the EVA Mission System Software Project is also working with GIS experts in Ares, and then we hope to be starting work soon with our colleagues like Fred with extensive experience at JPL, hopefully soon. Next slide, and then you can skip that one. One more. Thank you. So with that in mind, it's a fun idea to imagine what your data might look like here and how it can be used to help decision making. And all you need to do is put some time with it. So next slide. So then back to my original question, who's going to be benefiting from your part of the story? Next slide. So first off, the scientific community is going to find it easier to discover the context around your data. Operations and science backroom teams will make it easier, or will find it easier to quickly and efficiently make good decisions with the data, your data at hand. And then later on, maybe the general public will enjoy your data more when it's in an interface like Apollo in real time. Then of course you, in software, it's important to think about not just yourself as you're writing code, but other people who are reading your code. And a good mantra there is that you in the future count as another person. And in that case, I think it applies here as well, because the later version of you counts as another person. When you go back and look at your data, you're going to want to have the context around it to make it easier for you to remember the story about your research as well. And so next slide, please. And this is just a quick summary of basically everything I just said, but I'll go ahead and wrap it up here. So with that, I'll yield the last minute of my time. Thank you very much.
All right. Thank you so much, Cameron. Great timing and great talk as well.